In our previous videos, we discussed the basic notion of limits and how we found limits by approaching a number numerically. In this video, we are going to discuss how to find the limit of a function by viewing that function's graph. So to save time, I have already graphed this function. It's not the best graph, but you get the idea. But it's here. And we're going to use this to find the limit as x approaches 1, 2, let's say 4 of f of x. Okay, so let's find 4 on my graph. So here is x equals 1, x equals 2, x equals 3, and x equals 4. So 4 is right at this line, okay? So I want to make this very clear. My function here that we are discussing in this particular video, this is a linear function. Now, when we have linear functions, finding the limit is fairly simple if you really understand how to graph and how to find the point at that graph, okay? Because if I'm being honest, for linear functions where there is no stipulations, where there's no funny stuff going on, as long as it is a basic linear function, the limit would be equal to f of 4. And in this case, f of 4 is equal to 2 times 4 plus 1, which is 8 plus 1, which is 9. So that's a trick, okay? That's like a little hack for linear functions. But let's say I did not have a linear function. Let's break this down and look at this. How do I know for certain, that the limit is 4? So what I would do is I'm going to look at this spot. This is where x equals 4. You're going to find x equals 4 on the graph, and you're going to just draw a line up or down towards where the graph is. And what we're going to do, and this is what we did algebraically or numerically in previous videos, we substituted values from the left into my function and got the outputs. And if I were to do that for this particular function, let's say I were to plug in 3.9 and 3.99 and 3.999, what would happen, and I'm fairly certain that my y values may not be exactly these numbers, but it would be something like 8.9 and 8.99 and 8.999. What would happen is my values would inch closer to that value 9 from the left, okay? So now let's look at it from the right. So looking at my function from the right, numerically, what we would do is we would substitute values in that is near 4, but on the right side of 4, so somewhere over here. So that would be values like 4.01 and 4.001, and you could put in as many as you would want, but I can tell you what would happen. My y values are going to get closer and closer to the number 9. So I don't know. I haven't actually plugged these numbers in, but I would assume that it would be something like 9.01 and 9.001 and 9.0001. That should have been another 0 there. But that's what would happen. You could see that in both cases, both of these patterns, they are approaching 9. So from the graph, I can see that the point there is at 9, which lets me know that the limit exists there. There's a nice linear function. There's actually no hole in my graph there. There's a point there, so the limit does exist. The limit is that point, it's 9. But if there was a hole in the graph, then you would have to do what I just did by looking at the graph. And we would say, what point would be there, or what point could be there, or what is my missing point? What if my patterns were to continue from both sides? If I were to continue from my left and continue from my right, where would those patterns meet? And in this case, my patterns would meet at the number 9. That is where they would intersect. So I can say in this case, and I am up here now, that the limit as x approaches 4 of f of x is equal to 9.